Hello everybody, this is Mrs. Slater, and today we're going to talk about two things: graphing to find the intersection and substitution to find the intersection. So before we begin, there are a few things we need to go over, and that is the graphs of two linear equations can be intersecting lines, which is what we'll see the most. You could have two parallel lines where they don't intersect at all, or they could be the exact same line. Let me show you an example of each. Okay, so the first one, if we had two lines, let's have a red line going in this direction and a purple line going in this direction. It's not necessary to get your graph sheet out for this. You can just make a sketch in your notes. But do you notice where they intersect? And I'll put that in green. Right here is the intersection point. So we call that the intersection or the solution, but we would always name an intersection as an ordered pair. So keep that in mind for the problems. Next, if we have two parallel lines, you are going to see a picture that when you graph it, they will not intersect at all. And if you see any equation with the same slope, then that can be a way to reemphasize the fact that they're never going to intersect. So that's another way you'll see a picture. And the last one is not as obvious because it'll just look like one line. So let's say, for example, the first line you graph looks something like this, and then the next one looks exactly the same. So it's going to lie right over the top of the original line. Okay, so what that means is if you have just intersecting lines, there is going to be one solution. If you have parallel lines, there's going to be zero solutions or zero intersection points. And then if they are the exact same line, there is going to be infinite amount of solutions. Okay, so let's go ahead and do some practice problems. To find the intersection of two lines by graphing, there are a few steps. So please push pause anywhere along the line just to make sure that you are getting everything written down in your notes. So to find the intersection, step one, you are going to solve for y because that's going to help you graph it. Step two, you're going to graph them both, and then wherever they intersect, you're going to write it as an ordered pair. So just to remind you what I said in the previous slide, there is what we call the intersection point, so you may be able to find that, and that's the exact same thing as finding a solution. And again, it should be written as an ordered pair when you are with the final answer. Okay, so let's look at the first one. 2x plus 4, y equals 6. So we need to solve for y first. So that would be 4y equals a negative 2x plus 6. And if I divide everything by 4, I am left with y equals a negative 1/2 x plus 3/2. Okay, now let's do the next one. This is a system because there are two variables that we have to solve for. And the next one, 0.5 is just another way to say 1/2 plus y equals, and 1.5 is just another way to say 3/2. And if I move the x over just to get it into slope-intercept form, you'll notice that they are exactly the same line. So when you put that on the graph, you're only going to see one of them. So you would go up 1.5, which would be about right there, and then down 1 over 2. So down 1 would be here, and then over 2. Down 1 over 2. So you're going to end up in the middle of each one of them. Okay, so I'm going to get my handy dandy segment tool here and connect them all like so. And it looks something like that. Little arrows to symbolize it goes on forever. Okay, and then since they are the same, the other line is going to be right over the top of it. So if it's asking you what the solution is, you would say infinitely many solutions. There's so many there, we cannot write them all down because it lays on top of each other. Okay, so anytime you see a graph from now on, I gave you a note sheet, or no, I mean the graph sheet in your packet. So those would be very convenient to draw some of these. Okay, so let's go on. The next one is 3x minus 6y equals negative 6, and 5 plus 5y equals 20. So go ahead and push pause and solve for y. Okay, so let's check your answer. So hopefully you have both the purple equation and also the green equation. So now let's go ahead and graph both of them and see if we can find an intersection point. The purple one starts at 1 and then rises 1 and runs 2. So I'm going to show that on my graph. Go as far as you can either way just to make sure it is a nice graph, because you're going to want that to be very nice. And then the green one starts at 4 and goes down 1 over 1. So we end up getting a very nice intersection point at right there. So the intersection point, or the solution, is 2, 2. Alright, so I want you to go ahead and practice the next one, and only one of them you're going to have to solve for y. Go ahead and push pause and solve for y. So hopefully you put 3y equals a negative x plus 18, divided everything by 3, and that y equals a negative 1/3 x plus 6. And let's graph. Plus 6 would be here, and then down 1 over 3. Down 1 over 3 continues in this way. And when you connect, looks something like that. Alright, and the other one we're going to put in red, and that's y equals negative 1/3 x minus 1. So we would start at negative 1, and then we'd go down 1 and over 3, because it is a negative, and continue going down 1 and over 3 to find the line. And that line is going to look something like this. Okay, so as you can see from the picture, you have parallel lines, and you can also double check with your slopes. They are exactly the same. So you know that there is going to be zero solutions, no intersections at all. Now, I would like you to go ahead and push pause and practice this one, and then tomorrow in class we will go over it. Okay, so now let's go ahead and go on to the substitution method, which is our second goal. Okay, so push pause anywhere along the way just to make sure you have everything written down. We're going to find the intersection of two lines using substitution by these following steps. We're going to solve for x or y, depending on which one is the most convenient equation. And then we're going to take that new x equals or y equals equation and plug it into the other. Plugging it into, that is what I mean by substitution. Okay, so let's go ahead and look at the first one. Solving for substitution, we're going to solve for y, because that would be the most convenient. And what I mean by that is that you're not going to get a fraction. So y equals a negative 2x plus 6, and that's going to be replaced with the y equals in the second equation. So it would look like this. 3x replaced with the new negative 2 plus 6. So you're actually substituting it in. Now we have one variable, and we'll be able to solve. So 3x plus a negative 8x plus 24 equals 4, and negative 5x equals a negative 20, and x equals 4. Now you can't stop there, because we know that all solving of systems is going to be an ordered pair. So we have to take the 4 now and plug it into one of the originals. So you can go back to the 2 originals, or you can go to the y equals. I choose y equals. It makes it go a little faster for a final answer of -2. So we can't stop there either because a solution is an ordered pair. So the final answer would be 4, because that's your x value, and -2 because that's your y value. And there it is. Okay, so on the next one, what would be the most convenient is what you should be thinking about when you start these problems. And then you notice that in the bottom equation, there's an x all by itself. So that is going to be the most convenient variable to get by itself. So the first one I'm not going to do anything with, but the second one I'm solving for x, which will give me a -5y plus 3. So I'm going to take that value, plug it in for the for the x, and solve. So 2x plus 7y equals 3, and I'm going to replace -5y plus 3 in for the x. Now I only have one variable to solve for. So when we simplify, it ends up being distributive property, -10y plus 6, and -3y equals a -3, so y equals 1. And then plugging that in for the y here, x equals a -5 times 1 plus 3, and you end up with a -2 for x. And we can end with the ordered pair, -2, because it's the x value, always comes first, and 1 is going to be your y value. Okay, so for class tomorrow, I have 2 more for you to do. I do want to tell you that A's and B's are going to be the exact same things as X and Y's. Always think of them as, I'll put it in alphabetical order. So if you'd like, you can go ahead and substitute in X and Y for A and B if that makes it easier for you. And then another hint is on the second one. The first thing you can do is you can get rid of the negative or the decimals if you'd like, but in substitution, since you have a convenient one right here, you can just solve for y and plug it in. Alright, so that's it for today, and make sure you have the practice problems done before class tomorrow.